Hello everybody, welcome back to the show. I'm out of laundry, so I gotta wear this shirt today. Welcome to my cardboard arts and crafts YouTube channel. Today we have to make the dispenser. I just remembered I have one more 12-volt motor. Plugging this into the ground. Plugging this into the... Jesus. I'm killing it. I'm killing it. Whoa! But it's like a torrential downpour. I think I'm just gonna get like a conveyor belt type of deal. Or I'll make my own. Because it has to be flat. So a conveyor will solve the issue of... I think... For now, man, I tried. Every device that you have that has a battery in it has a circuit that cuts off power when the battery is too low. So last summer, I actually built a circuit. Our battery is connected to our discharge protection circuit. So nothing's gonna turn on until I press this power button. Ah, you see that? And then the voltage is dropping. So now we're at 3.57, 3.56. Like for example, battery dies. What should happen is this opens up, it pushes the battery out, and then it calculates how much capacity this battery has. So this thing right here is drawing a constant almost 1 amp of current. When I press this switch, our battery is turning this circuit on, which is connecting the battery to our dummy load. And that is going to tell us how much current is being drawn from the battery. I have the whole day today to just like connect all the code with the hardware. Whoa. What? I'm so confused. Location is never being updated. That should work now. Oh! Oh! That connected. I've connected the battery. When it says pressing battery on, we see the light go on. Okay, bro, that works. Start a timer to time battery life, and then we have to turn on our battery protection circuit. We're basically gonna be stuck in this loop while our battery is like discharging. So if we're given milliseconds, I think all I have to do is just divide it by 3,600. I think that's the magic number. This is the first real test. Oh, connected. What? Okay, that's broken. Connects the battery, 3.91 volts. Turns that on. Okay, that's a problem. Oh, it works. Seems to be working now after I let the smoke out of the potentiometer somehow. I just got to be very careful. Wow, we've been monitoring for like 30 minutes. This is like 500 milliamp hours. Dude, it just did it. Okay, it just cut off. Milliamp hours, 466. Remember, I'm just like, yo, it's around 500 milliamp hours. So it cut off at about 2.52 volts. That's perfect, actually. This is from the air conditioner. First year, that was the first real electronics project I did. Dorm room air conditioner. So I've just added 2 new small features, a red LED. This LED is gonna go off when there's an error. And then there's a switch here. So if it tries to connect the battery and it fails, it should, 3 times. If it fails 3 times, it should light up this LED. And now it's trying one last time. And then it's like, yo, this isn't working. So it lights up this LED. It's getting better. It's getting closer. I keep running into problems. So many problems. All the batteries I just quickly tested that I thought were like awful. They're not as bad as I thought because there was a weird thing in my circuit here. That's a bad one. Over there. What about this one? Oh, I got caught. Oh! It fixed itself. It fixed itself. It's still dead though. This battery looks half decent because it's drawing 1 amp, right? So like you guys can see now how this is the reason I wanted to build this thing, because it'll just log. It's so much easier. Oh, this one's good too. Look, 4, but then it drops. You know, pretty close. But it's able to draw 1 amp. Because we're drawing such a high current, it should last for 2 hours. Well, the good ones should last for 2 hours, 2 amp hours, so 2,000 milliamp hours. And it looks like these guys are pretty solid because they've been sitting on my desk for a year, and they're still able to draw 1 amp. Sweet. Dude, this is like a real machine now. Well, dude, imagine if I had the stack going, like, I don't know, it's looking pretty cool. It's looking pretty solid. Milliamp hours are calculated, right? That's all we want. We just want to see 29 milliamp hours. Does anybody know how to make a conveyor belt? I've never made a conveyor belt, so I don't know. Because I want to start actually doing things with these batteries. Like, imagine when I'm in the wilderness or something, man, and like I need like a new camera battery. You pay Canon, I think $50 for one of these batteries. 1,120 milliamp hours. These batteries are supposed to have 2,000 milliamp hours. I pay $1 for these. Imagine if I have 10 of these batteries. I don't know, we can do crazy stuff. And 10 of these isn't even a lot. When you're looking on my desk right now, you're probably seeing about 60 batteries, but I have another 84 batteries down here that I still have to like rip out of laptop batteries. So I have to like rip those out.